Given that a line passes through the point A having the coordinates 1, 2, and it forms an angle of 60 degrees with the x-axis, and also it intersects the line x plus y equals to 6 at the point P. Determine the length of the line segment AP. Okay, let's try to understand the problem graphically first. So here we have a line which passes through the point A having coordinates 1, 2, and also it's forming an angle of 60 degrees with the x-axis. It's also given here that this line is going to intersect another line x plus y equals to 6 at the point P. Okay, so let's say this particular line is going to intersect another line at the point Q. So here we have the line with the equation x plus y equals to 6. So it is intersecting the previous line, let's say at the point Q. Our goal will be at the point P. So our goal will be to determine the length of AP. So to find the length AP. Okay, fine. So here we can see here that the original line, so let's call it the line L. So the line L is passing through 2 points. One of the point is the point A, 1, 2, and the other is the point P, which is the intersection with the other line x plus y equals to 6. So here what we can do, we can use the distance form of a line to represent the equation of line L. So equation of the line L using the distance form, we're going to have, so first what we'll need to specify the coordinates of point P. So let the coordinates of point P be x, y. Then in that case, we'll take the difference of the x coordinates. So we have x minus 1. So 1 is the x coordinate of point A divided by cosine of the angle that the line L makes with the x-axis. So here in our case that's 60 degrees. So we get x minus 1 over cosine 60 degree. That is going to be equals to, next we take the difference of the y coordinate. So we have y minus 2 divided by sine of the angle 60 degrees. And this is going to be equals to r, where r is nothing but the distance between the points A and P, or we can say r is simply equals to AP. Fine. Now what we have here is x minus 1 divided by cosine of 60 degrees. That's equals to r. And we have y minus 2 divided by sine 60 degree. So that's equals to r as well. So here we can isolate x, and that is going to give us 1 added to r times cosine of 60 degrees, and then we have y equals to 2 added to r sine 60 degrees. Now we know cosine 60 and sine 60, both of them have their standard value. So x is going to be equals to 1 plus r. Cosine of 60, that's 1 over 2. So we're going to get r over 2. Similarly, y is going to be equals to 2 plus r times sine 60. So sine 60, that's square root of 3 over 2. So we have 2 plus square root of 3 over 2 times r. So what we have done here is we have represent the coordinates of the point P in the parametric form. So here we can say that the coordinates of point P, which is initially we assume to be x, y. So this is also can be represented in the parametric form as 1 plus r over 2, 2 plus square root of 3 over 2 times r. Now here we're going to use the fact that since the point P lies on the line x plus y equals to 6, we can say that this point is going to satisfy the equation, meaning we can replace x and y with the coordinates of point P represented in a parametric form. So let's do that. So in place of x, we have 1 plus r over 2 added to y. So in place of y, we have 2 plus square root of 3 over 2 times r equals to 6. In other words, we have 1 plus square root of 3 divided by 2. That will get multiplied to r. That's equals to 6 minus 2 minus 1. So that will be simply 3. Or we have r equals to, cross multiplying, we get 6 over 1 plus square root of 3. So that is going to be r. And what is r? R is nothing but AP. So there's, as we have successfully obtained the length of AP. So AP comes out to be, if we want, we can rationalize the denominator. So that's going to give us 3 multiplied to square root of 3 minus 1 unit. So this is going to be the length AP.